Okay, so today we're going to do the first part of our note on our weekly schedule, and we're going to be taking a look at trying to figure out the weekly warm up, the daily warm up, and then also take a look at nuclear decay today. So I'm going to share our screen again for our notes, and again, you guys should have this. I would make the note myself. That way, you have your own copy, and then you can kind of study it and do everything you need from there. Yeah. So the plan for the week again today, we're going to do the first couple of slides today, and then we're going to begin a weekly activity part one. The Gizmo part one is going to be due on Wednesday, which we'll talk more about that in a couple of minutes. So when we get to that point, Wednesday we're going to finish up the slides and do another quick little activity. Then Friday, no new slides or anything, but we will get ready to. Anybody else having trouble hearing me? Okay. All right. Well, sorry. Hopefully it sounds a little better. No, I'm not sure, Peyton. Sorry. On Friday, Peyton, you can just follow along. You can even mute me if you want. I'm just gonna go over the slides. Um, on Friday, we're not gonna do slides, but we are gonna do a weekly quiz. So on Friday quiz is it's gonna be locked right now, but it will be opened up in the morning and due at midnight. I will give you time during class to take the quiz, and then of course I'll be available to kind of help you out with the quiz as well. During class time. So. All right, so weekly quiz, just kind of talking about it. The information can come from any of the slides that we do on this presentation, anything from activities that we do in class, especially the Gizmo that we do on Monday and Wednesday. And then any question and answer sessions, anything that we discuss in class, the quiz question can come from all of that. The quiz will be randomly generating questions, so not everybody can have the exact same quiz information, the exact same quiz. So just kind of be aware of that you're going to be getting your own unique quiz just for yourself on that. All right, so day one today, Monday, we're going to be talking about our module 5 and talk about nuclear chemistry. And so, nuclear chemistry, you can be talking about the nucleus itself. So, you guys had a daily warm up. And if you remember, we were talking about isotopes, we were talking about mass and number of proton, neutron, electrons in the atom. So let's start off with talking a little bit about the daily warm up. So in the chat box, I like to see all of you answer as fast as you can. In the chat box, what is the mass number of this symbol? All right, it looks like you all got it. Awesome. Yeah, so 48 is the mass number. Remember, the mass number is always going to be the highest number that we can have in our atom, so to speak. And And remember, the mass number is protons plus the neutrons together, so they're added together on it. All right, so what is the atomic number? Yeah, so it's at 22. You're given information in your handout or on that symbol. You're given the information about the atomic number, and you're given the information about the um, of that. So, all right, number of protons. What's the answer for that? I got one person with. All right, very good. So the atomic number is also the number of protons. So the answer there is 22. Okay, and then number of neutrons. What's the answer for that one? We're getting different numbers now. So the answer is 26. How did we get 26? Somebody want to show me the formula in the chat box? Yeah, so it's the mass number minus the atomic number. That's how you get the number of neutrons. Note that number of neutrons is larger than number of protons. That will normally be the case. Okay, you would normally have more neutrons than protons. The neutrons are the glue that's holding those protons together. Those protons don't want to be together. They're all positively charged. Okay, they want to repel each other. Remember, opposite charges attract, positive, negative attract. The same charges want to repel each other. The protons don't want to be together. So they need glue holding the proton together, and that neutron are that glue. And you typically need more glue to hold those protons together. And that force, we call that strong nuclear force, that glue is holding them together. All right, and then last question there, the electrons. How many electrons do we get? Okay, Nick. All right, so the answer is 22 because you have to read the slide carefully. It says they neutral isotope, so that means that the proton and the electron are the same. Okay, so they are neutral. So if you have 22 protons positive, you're gonna have 22 negative electrons. So in order to cancel each other out, in order to be neutral. All right, I think Michael asked, or Owen asked this question earlier. So using the periodic table, what is the element name, mass number in the box? You need to write the whole name with the math number at the end. Yep, I got it. So in that box, you write the whole name in the box. So Rylan, Noah, getting it there. So yes, this is the element or isotope called titanium 48. And you probably were with things like carbon 12, carbon 14. You know, those are isotope names. Carbon 12, carbon 14, uranium 238, 235. Those are isotope names on there. Okay. Hydrogen, you get hydrogen 1, hydrogen 2, hydrogen 3. You have different isotopes, so we write the name with the mass number, just like those guys did there in that example. So good job. Awesome. All right, so let's pick up the notes from there. And again, in order to write the isotope, you can do it a couple different ways. Again, in this example here, you have the name with the number there, just like that. Or you can also do the symbol with the mass number, TI 48. Or you could do what's called the nuclear isotope symbol, like this. The mass number on top, the atomic number on bottom, with the mass, with the symbol TI there as well. So different ways to all write the exact same thing. So again, if you want, I would encourage you to have paper, pencil, kind of follow along with this. Okay. All right. So today we're going to talk about radioactivity and nuclear chemistry. What's going on with the nucleus sometimes? So sometimes the atom is not stable, and it happens quite often actually. And so, in order to stabilize the atom of the nucleus can get rid of particles or get rid of energy, and that is called radiation or radioactivity. Is that when energy or particles are being emitted away from the atom. So if the atom is too unstable, say, hey, I need to get rid of some protons, throw the protons out, okay, in order to become more stabilized. Everything in nature, the second law of thermodynamics, everything in nature is going to become more stable over time. That's just what it wants to be. It wants to be simple, and so atoms are going to do the same thing. If they're too big, they're going to just simply break off particles, and we call that radiation. Right? And it's natural. It's natural. We have radiation in our world, especially what we call background radiation. Then of course we have unnatural sources of radiation, and we want to be more careful about. So the types of materials that give off this radiation are called radioisotopes. So they are isotopes of atoms that are radioactive, they're unstable. Okay? You have an unstable nucleus in the middle, which is why we call it nuclear chemistry. When an unstable nucleus undergoes decay, it breaks apart and it will actually become an entirely different atom or element, okay, in that process. And so, especially if it's going to emit proton particles, it can actually become a smaller atom by getting rid of some of the protons. So, if carbon had 12 protons, it's like, hey, I'm not happy, get rid of one, okay? Like carbon only has 6 protons, but if carbon has 6 protons, get rid of one, it can go down to 5 being boron, okay, if it's not happy. And so if atoms are unstable, they can undergo a process called radiation or radioactivity. Okay. So unstable nuclei, we have particles or energy that they can give off. There are 3 main types of radiation that we're going to focus on in high school. There is more types of radiation that you'll focus on in college chemistry or advanced chemistry. They're not really all that common. These 3 forms of radiation are the most common. They're called alpha, beta, and gamma. You probably have heard of alpha, beta, and gamma before. Gamma radiation, we'll call it the Bruce Banner to turn into the Hulk. That's not going to happen in real life. Gamma radiation is actually really dangerous. You don't want to be exposed to it. It can change your DNA, but not in a way that's going to turn you into a superhero. It's going to turn you into a puddle and not going to be good for you. So gamma radiation, not good. But today we're going to focus on alpha radiation or alpha decay, which is probably the most common form of radiation out there. So, if you look at the bottom there, we're going to focus on this, and today's activity is going to focus on alpha radiation as well. All right, so this is where we really need to kind of understand what's going on and make sure that we kind of picture what's happening here. So alpha radiation is a helium particle, a helium nuclei. So a helium nuclei has 2 protons, 2 neutrons, and it has a mass of 4. Hope everybody's with me so far on that. Okay. If an atom is unstable, one option is that it can spit out 2 protons and 2 neutrons, called a helium particle. Okay, and we call that an alpha. Okay. That will reduce the number of protons by 2, which can be a good thing, especially if it's too large. The atom is too large, and like, hey, I have too many protons, protons don't want to be next to each other. Let's get rid of 2 of them. Okay? And that can stabilize that atom. This has a charge of +2 because it only had 2 protons that it's getting rid of. It did not get rid of any electrons or anything like that. It has a mass of 4, so it's getting rid of quite a bit of mass for the atom. There are common sources, lots of common sources of alpha radiation. Penetrating power. If the atom spits out this helium particle, it can go flying at things and go flying at you. The good news is though, is that it can't really go through your skin or even your clothes. It's going to kind of bounce off of you because it's too big. It's a helium particle. It's like the helium in a balloon. It's too big to go through things. And helium trapped inside that balloon for the most part. Same thing's going to happen. It's going to bounce off of you. But it is radioactive decay. What if you open your mouth and you get helium, you get the alpha particle in your mouth? So now it's stuck inside your body. And it's going to bounce around your body like crazy. And it can cause damage in your body. So outside your body, alpha radiation really doesn't do anything to you. But if you get it inside your body, it can cause quite a bit of damage as it bounces around in your body. Okay, so for the most part, alpha radiation not really going to be that big of a deal. If you're exposed to a lot of alpha radiation, you can just simply wear a mask, wear goggles, those type of things, and be protected for the most part. So paper, clothing, all that kind of stuff can stop alpha radiation. So an alpha decay here is an example here, and what we're going to do today is kind of write formulas for alpha radiation, alpha decay. A CAT scan. Most of them would use X-ray radiation, which is not alpha. It's not quite as high as gamma, It's a little bit weaker than gamma radiation, but it's not alpha or beta. It's not a particle. It's just energy that they use to go through. You can use gamma radiation. We use gamma radiation. Have you ever heard of, like, for cancer patients, they get radiation? That radiation is gamma radiation, going right through your body. They're pinpointing the target cell, and they're trying to damage the target cells that are bad, and so they send radiation into people to try to target those cells. And bad part about radiation is they can also kill good cells, healthy cells, too. But it can be worth it, to kill a few bad cells and good cells. Make sure you get rid of cancer. All right, so alpha decay. Oftentimes, we're talking about large nuclei that need to break apart into smaller ones. So they need to get rid of bigger particles. They need to get rid of two protons. So you see a formula here. This is radon 226. Radon has an atomic number of 88. If I get rid of an alpha particle, or 2, that will make my atom smaller by 2, go to 86, and smaller by 4 mass to go down to 222, and that actually changes my element to radon, or radium, okay? From there, this is more stable than the radium before that, okay? The radon is more stable than the radium, okay, because it's getting rid of the particle, making it smaller and smaller and smaller. During alpha decay, gamma radiation is typically released, but we're going to talk about that later on there. So if you look at the picture, you start off with a bigger atom, and you become slightly smaller, and you spit out a helium particle, and that slightly smaller nucleus is hopefully going to be more stable. And if it's not stable, then the radon can do it again, and can do it again, and can do it again. Okay, so you can keep doing that from there. Uranium quite unstable. Uranium-238 will actually undergo 12 steps before it becomes stable in there, because it's so big. It's such a large atom. So here we have some examples on this equation here. So again, we start off with radium-226. We lose 4. We make radon-222. Radium had 88 protons. We lose 2 in the helium, and we end up with 86. And for radium to radon. Okay. All right. So penetrating power, we talked about this earlier. Alpha is going to get stopped pretty quick. Beta does have a little bit more penetrating power. Beta particles can go through your skin, and we're going to talk about that a little bit later. When you get exposed to sun rays are beta particles. We call ultraviolet beta, and it can give you sunburns on there. Gamma can go right through your entire body, and it's only going to get stopped by lead or strong pieces of metal. And so gamma radiation is quite dangerous, because it literally goes right through your body. It puts a little itty bitty hole right through your entire body. But again, you're talking nanoscopic hole. You're not even gonna know. Your body's full of holes. Your skin's full of holes. That's how you sweat and everything. And your cells have holes. That's how things get inside out and out of your cells. But if that little particle goes through your cells and damages your DNA, when it goes through it, it can cause a problem to the cell. It can kill the cell. It can cause a problem with replication, cause cancer, things like that. So gamma radiation is really bad. Then, of course, if you have a bunch of gamma radiation and they all go through your body at the same time, well, that's a lot of holes you can put through your body, and it can kill you in a matter of seconds. So you have to be real careful with gamma radiation. And we'll talk more about that a little bit later as well. All right, today we're going to do a part 1 gizmo. And so on your weekly schedule, you see the documents and nuclear decay activity part 1. On there, there's a worksheet I'm going to ask you guys to work together with. This assignment is going to be due on Wednesday. So if we do not finish it today, we are going to finish it tomorrow, hopefully, during class. But you guys are going to have 15 minutes right now to help each other out on that activity. What I'm going to do, is I'm going to put you guys into breakout groups. and you guys can work together on this assignment. Even though you are working together on this assignment, please don't just copy off each other. Again, if I see copying or anything else like that, everybody's going to get the 0. Everybody's going to have to redo it, even if you were the person who did all the work. So no copying. Okay. Any breakout group, talk to each other, share your screen, walk through the Gizmo, walk through the activity with one another, and kind of look at what's happening for alpha decay. Well, we're going to focus on alpha for today. I don't expect you guys to finish this right now during class time, but you have it for homework. You can do it tomorrow as well. It is due on Wednesday. And again, we'll have a little bit of time tomorrow to finish up this activity as well. So
should we already have access to that gizmo?
you should. Wait a minute. I probably didn't put it up today.
Okay.
Let me pull it up real quick. You guys are my first and only chemistry classes, so all the mistakes happen to you guys. All right, it should now be on there. Yeah, if it's not part of your class, you only get 5 minutes to play with it. But now it's part of your class, so you can play with it for as long as you want. All right, so you might have to refresh your screen. All right, let's go into breakout groups. When you're in a breakout group, I can see everything you're doing. I can see everything you're chatting and typing about. It is expected you guys are helping each other and talking to each other, and help actually do a breakout group with one another. So I'm going to put 5 breakout groups here. Just going to randomly put you guys in the groups, and then help each other out. Okay. So I will be jumping into rooms and talking to you guys as well. So have fun. Something. If Island it's not working for you, you can just kind of work on it by yourself. If you have any questions, let me know. Alrighty. Hopefully that went well. The breakout group. Hopefully you guys got to kind of help each other out, ask questions if you guys need anything on there. Of course, if you need to ask me any questions, by all means do so. You can always do a private chat or email or whatever on there. I did not expect you guys to finish that today. We will have a little bit of time tomorrow to work on it during our Tuesday lesson before we do our professional habit lesson. But again, you have everything you need to do tomorrow's work, today's work, etc. I will be updating Wednesday's assignment today, and then you will have everything that you need to get the work done for the week. So today's assignment is due on Wednesday. Wednesday's assignment will be due on Friday. So you'll have a couple of days to work on each of those assignments. Again, you could do it for homework. You could do it, during class or whenever. Just make sure you are working on getting those assignments complete. The warm ups, we did the warm up together in class. Please make sure that you are, thinking, make sure you're taking those seriously because they are going to be part of your grades now. All right. As always, if you guys have any questions, need anything, please let me know. Otherwise, I will see you guys tomorrow at 9:40, just like we did today. And again, if you need anything, just let me know. So I'll see you guys later.